topics like universe, star formation, and then solar system. All these topics come under astronomy. So this is a low yield topic, that is the cost to benefit ratio is too low. So you can reserve this topic for future preparation, that is once you complete all the easier topics, then you can go for these kind of topics where the weightage is too low. But this concept, that is nebula theory of Laplace, is somewhat important. So to explain this, we need to know about star formation and universe, and also there are few multiple choice questions asked from these sections. I'll not go in depth, I'll just give some basics. It is a topic which is closely related to science, so it would be hard for humanities students to understand. I will try to keep it as simple as possible, but in case if you don't understand this topic, just you can leave it because it is not a high yield topic. So coming to topic, so what is universe? Universe is all that matter we see around us. It includes stars, planets, and then space between these planets, etc. So galaxies are the major building blocks of the universe. There are about few billion galaxies in the universe, with each galaxy having few billion stars. And the age of the universe is said to be about 13.8 billion years. That is, the universe came into existence nearly about 13.8 billion years ago, after an event called as Big Bang. This term Big Bang is important once. So what is this Big Bang event? Big Bang event is the prevailing cosmological model that explains the existence or the evolution of universe. According to this theory, universe is a small point. In the beginning, the universe was a small point with high amount of energy, where it occupied least amount of space, that is, it was just a point source with an energy of about 10 to the power 32 degrees Celsius. This is extremely huge amount of energy. And soon after the Big Bang event, there was an inflation in the universe. So the word inflation is important. So inflation simply means that the universe expanded in size, that is in volume, and the temperature started falling. So it took only about very small amount of time. You can imagine 10 to the power minus 43 or 10 to the power minus 32 seconds. These are very small quantity of time. So we need not remember this time scale or any important temperature lists, etc. We only need to know about these important terms like inflation. So after the inflation, the temperature fell significantly from 10 to the power 32 degrees Celsius to 10 to the power 27 degrees Celsius. And at this time, the universe was very hot, and there was formation of electrons and quarks. So quarks are fundamental particles of universe, which are tinier than protons, neutrons, and electrons. So they are fundamental to the formation of basic subatomic particles. After the quarks were formed, and after a time span of 3 minutes after the Big Bang event, the universe gave rise to few subatomic particles, or the main subatomic particles like electrons. Electrons were previously created, but other particles like protons and neutrons came into existence. Once these particles came into existence, the temperature started falling significantly. At this time, the temperature was still considerably high that light could not escape, and there was no shining or light in universe. Universe was still dark. But after 3 lakh years, the first light emerged. It is called as cosmic microwave background. At this stage, the electrons combined with protons and neutrons to form atoms. You know that atom has a dense nucleus with protons and neutrons in it, surrounded by a shells of electrons, where electrons keep on revolving around this nucleus, or so this is the structure of atom. So atoms were born, and after few billion years, these atoms started coalescing or combining under the influence of gravity, and this coalescence of atoms gave rise to small clumps of matter, which further gave rise to galaxies, and in the end there were billions of galaxies. And after 15 billion years, it is said that galaxies would start converging, and this event is important. This event coincides with the first death of stars. So usually a star has a lifespan of about 10 to 15 degrees, 10 to 15 billion years. So at present there is no significant death of stars, as universe is only about 13.8 billion years. So after 15 billion years there will be significant death of stars and the universe starts converging, and then they will start an event called Big Crunch. Big Crunch is an exact opposite of Big Bang. In Big Bang we know that there is expansion of universe, that is universe is expanding from a single point source. It has given rise to galaxies, and the space between galaxies is increasing day by day, that is universe is expanding in all dimensions. Whereas in Big Crunch what we see is there is convergence of galaxies, that is galaxies come close to each other, and exact reverse process of Big Bang happens, where the world will collapse into a single point source of very high energy, and this event is called as Big Crunch. So we have talked about cosmic microwave background. Cosmic microwave background is the oldest light in universe. It formed after 3 lakh years after the event of Big Bang. This light is significant for a few reasons. One, it proves the existence of Big Bang theory, and also it explains the expansion of universe. So this is a very faint light which is observed in all directions, and it is very significant in observational cosmology or the study of universe. It proves 2 things, as I've already said. One is expansion of universe, other thing is the existence of Big Bang theory. So there is one more important concept called as redshift and blue shift. This theory is important in explaining the expanding universe. We know that in a rainbow there are 7 colors, namely V, I, B, J, Y, O, R. The white light that we receive from sun is usually a combination of these few colors. And let us see what is importance of this Vibgaya concept. We know that red has greater wavelength, that is why it is placed in the end. V has the shortest amount of wavelength, that is violet has the shortest amount of wavelength. Coming to blue, has significantly smaller amount of wavelength compared to red. So how is this concept important? When an object moves far away, then it moves from blue end of the spectrum towards the red end of the spectrum. As a result, it starts appearing, the red part of the electromagnetic spectrum will be visible to our eyes. Whereas when an object moves closer to us, then the object shifts from red end of the spectrum to blue end of the spectrum, and hence the object starts appearing in blue color. So this basic concept is important in explaining the expansion of universe. This is because a star which appeared blue for a certain amount of time suddenly starts shifting towards red color, which simply means that it is moving away from the observer. So this is important in explaining expansion of universe. And Edward Hubble is the scientist who first explained this theory of blue shift and red shift. So this Hubble's space telescope is always in news because it revolves around the Earth in lower Earth orbit. This is important. It is placed in lower Earth orbit, about 300 kilometers above the Earth's surface. And this telescope keeps on taking pictures of the entire visible length of universe, and these pictures give a great information about the universe. And this telescope, the name of the telescope keeps appearing in newspapers, so this will be an important topic for prelims. And then let us look at stellar evolution or formation of stars. Till now we have seen what is Big Bang. Now we will see what is stellar evolution. So soon after the Big Bang event, there was coalescence of atoms which gave rise to huge clump of gases called nebula. Nebula is a cloud of dust and gases. When triggered, or when there is an external force which triggers the formation of gravity, then the atom starts coalescing further, and this coalescence of atoms gives rise to stars. So in the event there are many stages of star formation. We'll look at each stage one by one. So in the first stage we have seen that nebula, there is coalescence of atoms in nebula, and this coalescence of atoms gives rise to stars. So nebula is the birthplace of stars, and the main gases of nebula are hydrogen and helium gases. This is because during the coalescence, during the formation of atoms, the first few atoms which were formed in huge numbers were hydrogen and helium atoms. So the universe is abundant with hydrogen and helium atoms. In the next stage, the stage is called as protostar. It is an intermediate state between the main sequence star and the nebula. At this stage, the star will coalesce and will form into a big, huge mass in the shape of a planet or a near equal to star, but it doesn't have enough energy to start nuclear fusion. So what is nuclear fusion? Nuclear fusion is a process in which an atom of hydrogen two atoms of hydrogen will combine to give rise to an atom of helium, and in this process there is huge amount of energy released. So energy is the resultant. So nuclear fusion results in huge amount of release of energy, and this energy is important in driving a star. So an exact opposite thing called as nuclear fusion is also there. Nuclear fusion is also called as atomic fusion, where atoms of two elements, an atom splits into two nucleus or two parts, giving rise to huge amount of energy, and this is called nuclear fission. And in stars what we see is nuclear fusion. That is nuclear fusion, F-U-S-S-I-O-N, fusion. So for a fusion process to take place, it initially needs huge amount of temperature. Whereas for fission process, you don't need initial temperature, all that you need is a neutron which can ignite nuclear fission. But in fusion, you need huge amount of initial temperatures to start the fusion process, or splitting or combination of fusion of two atoms. So in the initial stages, when there was a star formation, there was no sufficient energy for nuclear fusion to take place. As a result, the star didn't emit significant amount of light. At this stage, the star is called as protostar. And once this stage is crossed, the next stage is Titori star, and in this stage the star has just begun to fuse hydrogen atoms into helium at the core, and there is significant amount of release of heat, but still it is not that significant for the star to appear like a star like Sun. So in the next stage we see it is a main sequence star, just like Sun. Sun at present is a main sequence star. At this stage there is great amount of nuclear fusion process, so at the core, so there is great amount of release of energy, and the star looks very bright. In the next stage we see the stage of a red giant, where a star which is fusing hydrogen into helium will consume all the hydrogen and only helium is left. At this stage helium starts fusing, which increases temperature of the star. Due to this increase in temperature, the size of the star increases. So let us see on what factors does the size of a star depend. Initially there are two factors which influence the size of a star. One is gravitation, other one is heat energy. So gravitation is something which pulls the star's mass towards the center, whereas the heat energy creates pressure, which keeps on putting pressure so that the mass moves away from the center. And there is a balance between these two forces which result in an equilibrium, and there will be a certain size of the star. And in this case, once the fusion of hydrogen is exhausted or complete, there is fusion of helium, and during this stage the amount of energy released is too high. As a result, the heat takes an upper hand and the pressure is increased. As a result, the size of the star grows significantly. So the fusion of helium releases more amount of energy compared to fusion of hydrogen. So the size of the star increases significantly, and at this stage it is called as red giant. And at the core there is accumulation of carbon, because helium atoms fuse to form carbon atoms, just like two hydrogen atoms fuse to form helium. Two helium atoms fuse to give rise to carbon. As a result, there is a dense carbon core which is formed at the center, and once the fusion of helium is complete, then the energy that is supplied by heat is completely exhausted. As a result, the outer parts will escape to space, and the inner part, the dense carbon core, remains. That is, it is still tough and it remains, and this dense carbon core with escaping gases is called as planetary nebula. So it is a stage after red giant. Usually in star formation there are two kinds of stars which are formed. One is a small star, other one is a large star. These two stars have a different life cycle. For example, in a small star it reaches a red giant stage, In a large star, it reaches a red supergiant stage, that is, its size is so huge that it is quite large compared to the red giant. Usually our sun will move from star to a red giant stage because it is a small star, whereas other huge stars sees a different stage called as red supergiant stage. So at this supergiant stage, the star starts combining a lot of elements and give rise to iron, which is very dense and heavy, so it starts accumulating at the center. At this stage, once the fusion of helium and other elements is complete, the star has huge amount of pressure at the center, and at great amount of pressure, there is huge amount of energy released, and the star will undergo a death called as supernova event. So supernova is the death of star. Even supernova releases a lot of dust and gases into space, and these dust and gases are important in formation of new stars. So this cycle repeats. Just like in planetary nebula, we have seen that some gases escape to space, and these gases repeats this cycle of formation of stars. And after the sun explodes into supernova, after the star explodes, there are two different things that happen. One is the formation of neutron star, and the other one is formation of black hole. Also, black hole is the most densest object in the universe, which can even attract light, or we can even deviate the path of light, or sometimes it can completely consume light. Whereas a neutron star is a star, it is also called as degenerate matter, because in a neutron star, electrons and protons combine and fall to the nucleus, giving rise to a neutron star. At this stage, the size of the star is significantly reduced, whereas density is significantly increased. So a neutron star would be so heavy that even a spoonful of neutron star element would weigh some thousands of tons. Likewise, in the small star life cycle, we see that after the formation of planetary nebula and after the escaping of all these outside gases, there will be a stage called white dwarf. White dwarf is nothing but dense carbon core with all the gases lost. So it will still have some luminosity because of the existent temperature which is brought from this stage. So it is still comparatively hot and emits some light. But after this stage, after the total exhaustion of energy, the white dwarf will move to a stage called as brown dwarf. At this stage, the star completely loses its luminosity and appears as a black dwarf. It's not a brown dwarf, it is black dwarf. So in other case, we have seen it will be a neutron star or a black hole. So we have talked about red giant stage. Then we see there is a planetary nebula from small star, and then there is an event called supernova. It is in the case of a big star. You can study these points. And then nova is another important event. So this is the second way in which a super red giant gets converted into a supernova. Usually when a supergiant approaches a younger star, it pulls into it the hydrogen and helium mass present in the newer star. As a result, all this hydrogen and helium atoms starts to fuse at the core of the supergiant, and it will lead to a sudden explosion. This is also a supernova event, and this event of binary stars giving rise to a supernova is called as nova. So we have seen what is a white dwarf. Sun after its death will become a white dwarf. So black dwarf is what we see after white dwarf loses all its luminosity. So at this stage, there is no formation of black dwarfs because the universe is only about 13.8 billion years old, and for the formation of black dwarf, it usually takes about 15 billion years. So it is strictly a theoretical concept, but still in films, certain questions were asked on this concept. So what is a brown dwarf? Usually when there is coalescence of atoms, they will give rise to stars, but when there is little mass and there will be no sufficient amount of energy to ignite nuclear fusion, then the star won't be luminous, or it won't emit light, and will remain like a planet, just like other solar system planets. So this kind of planets with no light but still bigger than a planet are called as brown dwarfs. So they don't have enough energy to initiate nuclear fusion. I have told that nuclear fusion requires a lot of energy to start, and usually the energy is obtained from the gravitational force. As gravity pulls matter towards the center, it creates huge amount of pressure and then leading to huge amount of temperature, and this temperature is made used in the form of to ignite nuclear fusion. But as the star is not significantly in size, the pressure at the center is not significant enough to start a nuclear fusion. So this star will remain as a brown dwarf. So we have seen what is a neutron star. Neutron star is a very dense star formed by cancellation of electrons and neutrons. So black holes are the densest objects. They are the most mysterious objects in the universe. What exactly happens after black hole sucks a lot of matter is not known. So to easily remember these concepts, it is important to compare these kind of comparisons. So protostar is a fetus stage. It doesn't have exact proper shape. Still it is in the existence or evolutionary process. And then we see in the fusion process it will be a T Tauri star where it has just begun to start fusion process, and this stage is compared to a small kid. And then the main sequence star, a 20 to 30-year-old man. And then a red giant is like a middle age, very close to death. And then white dwarf is just before death. So there are 100 billion galaxies in universe. So each galaxy has about 100 billion stars. And the galaxy in which sun is present is called a Milky Way. And Milky Way is a galaxy which is a type of spiral galaxy. Again, there are three types of galaxies: elliptical, irregular and spiral. The sun is present in a Milky Way galaxy which is spiral in shape. Usually this galaxy is in disc shape, that is, if you look from horizontal view it would appear like a disc, and at the center is about 1 lakh light years away, and at the edges it is about 500 light years away. That is, 1 light year is equal to the distance traveled by light. So what is a light year? Light year is nothing but the distance traveled by light in 1 year. We know that light travels at a speed of 3 into 10 to the power 8 meters per second, and with this speed, if the light keeps on traveling for few years, then it would reach certain distance, and this distance will be equal to 1 light year. That is, the distance traveled by light in 1 year is 1 light year. So you can imagine how big the universe is if the galaxy itself is few light years across. So the sun is at a distance of 1/3 from the center. Usually the diameter is about 1 lakh light years, whereas the sun is at a distance of 33,000 light years, that is 1/3 the distance from center. So in the next topic we'll see about solar system. The first important topic is the nebula theory of Laplace.